All right. So you are welcome to the GMAETS 41's live class on ordinary differential equation. Say the GMAETS 41 is always on high alert. The academic firepower never goes off. 2 days ago, I think we rounded off with JAM students, having prepared them and of course wish them well for them to go and sit and do the best they can in the examination. But the truth remains, as a student follows up with the GMAETS 41's classes, according to how I coach you, if you are consistent, the same way GMAETS 41 maintains its integrity, commitment, and consistency, the result would right be there with you. That is certain. Now today I've kicked off the GMAETS 41's classes on ordinary differential equation for students in UNIZIK, Nnamdi Azikiwe University, 200 level students. This course is coded Max 202, just like you have it there. Okay, now there are 2 classes I'm going to run within 1 hour time or so, because this class was supposed to start by 7 though. All right, but just got to get prepared for the class, after which we're going to look at Math 101 for 100 level students. Is that okay? So what I really want to say is that this course is a simple course. In UNIZIK, there is this funny code, a code name given to it, because the acronym of this is ODE. And then in Igbo language, it is called by many students in UNIZIK Odiegu. Students fear this course like anything, but I want to tell you that this course is simple. The course is simple. All of this is a function of you getting a better coach, tutor to coach you. And here the GMAETS 41 is here telling you that this course is 1 + 1. First of all, in as much as I've declared live classes on these courses, right? This course and others, because Stat 202 statistics is coming, right? Organic chemistry 3 also, right? It's coming, aromatic compounds and their derivatives. On this channel, there are already pre-recorded videos that have covered the course outline for students. So you can always scroll through to the GMAETS 41's playlists on this channel. If you come to the home page of this channel, you have home, videos, shorts, live, playlist. You can make use of the playlist. If you click on the playlist, scroll, and then look for Math 202, ordinary differential equation. So if you are taking this course in any university, in the country, Nigeria, and even outside the country, if you're doing ordinary differential equation, here at GMAETS 41 is where you get the best of the best. Yes, you know you can always count on this channel. Now let us kick off. Here on the board you have solution to an ODE, solution to an ordinary differential equation. That is what this class is based on. So it's going to be a brief and fast one as much as I can, right? Because I still have class with 100 level students. So I'm going to dedicate 30 minutes or roughly 1 hour to this particular class, because we're just looking at this part. Now when you are dealing with ordinary differential equation, we have this introduction to this course. And the introduction to ordinary differential equation is built around 3 basic concepts. The first of it is the area of definition of ordinary differential equation, types of ordinary differential equation. Already in our WhatsApp group, for those offering ordinary differential equation, I had already dropped a video lesson, is pre-recorded, that treats the first part of introduction to ordinary differential equation, where we define what is differential equation, we differentiate between ordinary differential equation and partial differential equation, and then we talk about types of ordinary differential equation. When you come to the types, there are basics, right? There are factors upon which we state the types of ordinary differential equation. It can be based on the order of the ordinary differential equation. It can be based on linearity of ordinary differential equation, either linearity and non-linearity. So all these concepts, I've treated them. You can learn more. Slide through to the playlist on this channel. Search for my 202 on that playlist, and then you have the video lessons. They're already arranged for you. So I'll be hitting solution to ODE right away in this class. And we would start first by asking, what is the solution to an ordinary differential equation? If I give you a function, how would you know that this function is a solution to ordinary differential equations? So without wasting time, for our dear friends, I can see you guys connected already. You're welcome. Somebody's asking from which country. This class is streaming from Nigeria. Is that okay? It's from Nigeria. And you can also tell us where you are connecting from. That would be appreciated. Okay? That would be appreciated. So what is solution to an ordinary differential equation? I'm going to define it without writing it on the board, so you follow through. You want the notes? Slide through to the playlist. This stuff I'm doing is just for me to appear live and have on the spot class with you guys. Otherwise, the video lessons are already available. The academic firepower of the GMAETS 41. Solution of an ordinary differential equation. The solution of an ordinary differential equation is defined as a function, as what I said, a function which is free from derivative. Which is what? Free from derivative. And which when differentiated, which when what? Differentiated as many times as the order of the differential equation. Which when differentiated as many times as the order of the differential equation, and then substituted to the differential equation, and then substituted into the differential equation, will produce an identity. Will produce an identity, or satisfy the equation. Or satisfy the equation. Sometimes when I handle courses like this, I just laugh and I'll be like, we've spoken the grammar there. Oh my gosh, the brain is bubbling. What is all this? Calm down. This is GMAETS 41, and the aim of this platform is as simple as break down concepts for students so that they get to understand this. For scholars, let them get to know that this thing is 1 plus 1. And that is the simple truth. I will never stop saying that. If I give you a differential equation, which I abbreviate as DE, and I give you a function f of x, let me call the function f of x, and I tell you that this function is a solution. This is solution. This is a solution to this differential equation. This guy is solution to this guy. How would I know that this function f of x is a solution of this differential equation? Point number one, solution must be free. Solution of a differential equation of a dE must be free of d dx of any function. Must be free of d dx of any function. For you not to get confused at this point, let me just write it in words. Must be free of derivatives. Must be free of what? Derivatives. What does it mean? A solution of a differential equation should not contain this, that, like dy, dx. It shouldn't be there. It shouldn't be in anything you call solution of a differential equation. Point number two, that is why, in the definition I said solution of a differential equation is a function that is free of derivative. So that is point number one. Point number two, that function that you call solution must be differentiated or must be differentiable. That is something that you can be able to differentiate. So point number two, solution of a dE, a differential equation, must be differentiable, must be a function that can be differentiated. A function that can be differentiated. You see how I'm trying to break down the grammar so that the point will be very clear, right? So whatever you call solution to a differential equation, that guy must be a function that you can be able to differentiate. The question will now be, how many times can you differentiate a solution to a given differential equation? That solution can be differentiated as many times as the order of the differential equation. Do you want to learn more about order of a differential equation? I've got a video lesson on this channel, like I said, and in our WhatsApp group. I'm operating from Nnamdi Azikiwe University, alright? So usually we've got for our physical tutorial classes, of course, and I want to say this, I'm not going to run a physical class for those in 200 level this set. Take note, my classes for you guys is going to be online. You've come to a level where you want to appreciate online learning. That is actually one of the, easiest way you can make good grades in your courses. You are aware of that. At least you've run first semester. You find out that you hardly even have time for yourself. Class is fixed for you, and what happens? The lecturer just brings you in school, you stay, and you hear the class has been cancelled. You've got no choice. You don't have your own time. Your time is controlled by people, your lecturers, and anyway, I don't want to go into that. So most of you already understand what I mean by the fact that you don't have time. So the only way you learn this course is come here online, live. I'm going to be guiding you in areas that you need to, focus on in this course. And please take note, make sure that you're a channel member. So you can get access to key main videos that are meant for members only. And it's not only for Math 202, not for only ordinary differential equation, other courses, statistics, that 202, you guys are doing it this semester. So take note, right? As I'm teaching on maybe from Unisic, like I said, for those students, we've got a WhatsApp group for them. So if you are joining this class from anywhere, what would you have to do? Contact this number. GMAETS for the ones, WhatsApp contact, right? Send a message to it, indicate your name, where you are contacting us from, and your level of study. Yes, indicate this. Then you can specify perhaps the course you want to take with GMAETS. You'll be added to our WhatsApp group so that you'll be following up with our class updates. And then if I drop video lessons for pre-recorded video, which I want students to take before a certain live class, you will also be updated Otherwise, sometimes you might just come for the live class and you are confused of what we are doing. Am I communicating? Because I'm talking about order of the differential equation. Now, I'm not going to talk much about it. Maybe if I happen to pick a question, I might now make reference to it. I've already treated that. How? Through the pre-recorded video. Think the video lesson is there about 15 minutes or so. But as a student taking an online class, if it is pre-recorded, if it's a 15 minutes video, you want to double your time because you need to pause sometimes, fast forward sometimes, go backward sometimes, pause and meditate on what you are learning. That is how you learn online. Please take note of this. It's not movie you are coming to watch on an academic channel. So if I have something like a 15 minutes video, you have to double it for proper learning. If it's a 1 hour video pre-recorded, you have to at least make it 1 hour 30 minutes. Because at some point you need to pause. Some other times you need to go back for effective meditation. And at the end of that, you go for your exam, you blast your A. Nothing stops it. Nothing. I keep saying this. It's only when students refuse to do the best they have to do. For example, I've already sent information about this class, but the question will now be how many, for example, those from Unizik, how many 200 level students offering my 202 this semester have connected to this class? Gen Z, you guys call yourself, right? Take note that Gen Z or whatever is generation of last. Yes. If you want to activate your being a Gen Z to make life easy for you, you want to be serious. I speak being academically inclined because I've got nothing else to do with many other things, right? My aim is to assist scholars. You want to work hard. Work hard. To those in Unizik, school is resuming on the 28th. Plus minus 2 weeks from now, all academic work starts. And you'll be complaining that what you're learning from lectures, you don't even understand it yet. You have platforms like this you can learn. Most of you will be messing up. I wonder what you want to take to your parents. Please. We're not even talking about your parents, even you yourself. Making good results is also very good in life. So make sure you always stay tuned and connected. I'm saying this out of the love I have for you people. Otherwise, I'll just come here, teach, and get out. Advising you wouldn't be my problem. But the truth is that most times you need to be motivated. But while you are being motivated by somebody, you too motivate yourself. Motivate yourself. Make use of every good opportunities you have to learn. As school is resuming on the 28th, as to whether you make A's in your courses and other things start from that 28th of this month and even before. Some of you will wait until 2 weeks to exam, 1 week to exam. You start running up and down on how to understand a particular course. I told you this course is simple. But let me just be open. It's because of how well I understand this course. People that call it in Igbo or Diego, those that understand Igbo language, they know. Even if GMAETS, I've decided to reacronize the meaning of that to all the easy, which means it is easy. The truth is, this course is not funny. That's happened that some lecturers even are taking the course while trying to take some student video, then when they get stopped along the line. I've received so many messages from students, different schools. One from UniJobs had sent, that was last year, that what is being taught in lecture, he doesn't understand anything about it. He came across my video lesson and I was begging how he can get access to all of them. Please, please, please help yourself. I'm here for you guys, but as to whether you want to be helped, it depends on you because I don't have control over you guys. I only do what I am able to do, which is teach you. Talking about solution of the differential equation, I've explained 2 key things about anything you call solution to a differential equation. It should be free of anything d this, d that, dy, ds. I get it. It shouldn't contain derivatives. Point number 2, it should be a function that you can be able to differentiate. And I ask the question, how many times do you differentiate that solution? You differentiate it as many times as the order of that differential equation. You know, this was what took me to advising you and telling you I have taught order of a differential equation. Yes. Want to learn more? Send a message to my contact and you'll be added to our WhatsApp group. On the playlist, you have that video lesson, just a 15-minute video lesson dealing with that. Point number 3 about solution to a differential equation. I hope this part does not cut off. Point number 3, solution to a differential equation. Okay, let me say the derivatives rather. When the solution of a differential equation of a DE and its derivatives are, let me use a simple word, they are fixed into, as I are substituted. Should I use fixed into? Let me use substitute. It's an academic language that most people understand. So, are substituted into the DE. When the solution of a DE and its derivatives or derivatives are substituted, its derivative or derivatives are substituted into the DE, an identity is obtained, which means it satisfies the equation. The equation will balance. What you have on the left will be what you have on the right. Okay. So these are the things you should know about solution to a differential equation. Although I have given you the basic principle about solutions to differential equation, how you can actually find out that this guy is a solution to differential equation. When it comes to an examination, if it is theory, your examiner can ask you, maybe prove that this is a solution to that. That is, you are given a solution, a function. You are given a differential equation and you are asked to prove that this function is a solution to this differential equation. If you are asked such questions, this is the principle you apply. This is the principle. However, in some other form of exam where you are giving objective tests, CBT, computer-based, where you click options, in that case, you don't prove anything in examination hall. So most times examiners have this way of asking questions. You might be asked, which of the following solutions or which of the following primitives, because solution of a D is also called primitive, take note, which of the following solutions, which of the following primitive is associated with this differential equation? Which means I give you options, option A, B, C, D, as functions, as solutions. I'm now asking you which of them is the solution of this differential equation. So you now look at the options and select the one that is a solution to that differential equation. Then again, look at this other format of question, where the examiner now gives you one function and then asks, which of the following differential equation is associated to this primitive? Which means in the question, you are given a function. Supposedly, what is the solution of the DE provided? So you have option A, option B, option C, option D, possibly option E, as the case might be. And then in the question, you are given a function. And you are being asked, which of the options there, which are differential equations, which of the options in the differential equations will have the given solution? So these are various ways in which you can be asked question on this. In the case of theory, like I said, this is the approach. But what if the case where you are given a particular function and you are asked which differential equation has that function as solution? Will you still use this approach? GMAETS 41 is telling you no. That is not the approach being used. A better approach is used in that case to facilitate your work. This one is really used in the case of theory, trying to prove that this is a solution of that. This particular function is a solution to this differential equation. So let us switch it the other way around, where you are given differential equations, right? And then you are given a solution. and you are asked, this solution provided is a solution to which of the differential equation? In that case, you are not proving anything. You are going to solve that function given to you, and then that function, as you are solving, is like reversing the process. As you reverse the process, it is going to give you the differential equation that has it as solution. For that reason, I'm going to give an alternative definition to solution of a differential equation. So get ready as I give you an alternative definition of solution of a differential equation. I hope you are ready. Alternatively, solution of a differential equation is a function that is free of derivatives. Is a function that is free of derivatives, which can be differentiated, and simplified to produce the differential equation. I take that again. Solution of the differential equation is a function free of derivatives. It does not contain the this, the that, the y there, it doesn't contain it. Which can be differentiated, of course, as many times as the order of the differential equation, or which can be differentiated as many times as the number of constants, in that solution, in that function. And then simplified. And then what? Simplified. So you see the third approach no longer applies there. Instead of substituting it into a differential equation, no. In this case now, you know the guy is free of derivatives. You know it has now been differentiated. Once you get to this point, simplify to get the differential equation. A solution to the differential equation is a function free of derivatives, which can be differentiated as many times as the order of that differential equation, or as many times as the number of constants in that solution, and then simplified to produce the differential equation. Don't worry, you're going to do this and you will see it live yourself. Is that okay? You're going to see it. Please, as you come across this video lesson, this live class that is going on, do well to share the link to your friends who you know are offering this course. For those in UNIZIC, 200 level students, share this link to your WhatsApp group, to your departmental WhatsApp group. Encourage them to join. There are no two ways about it. You need it, and you need this platform. Yes, you need GMAETS 41, so that at least you'll be sure that this course is a walkover for you. Your A is 99.9999% sure. Yeah, I don't want to make it 100% because as an engineer, right, and those in the field of science, we've learned that there is no process that is 100%. That is in line with a second law of thermodynamics, right? There is always a loss. For those in engineering and food science technology, I'm going to be taking you guys in thermodynamics. It is coded for 242. I don't know if the code might be changed for you guys, but whatever the case is, we are waiting. Thermodynamics. It used to be coded FEG 242 for engineering students in 200 level. Alright guys, I think I have defined solution to differential equation. So you see, I took my time on this concept and also to advise and encourage you, and also discourage you from any discouragement that you might be facing. Pull you up so you know the right thing to do. The reason I took my time is, you see, this solution very important, because when you come to differential equation, if I give you any differential equation and I say you should solve it, it is the solution that I'm interested in. And in almost all of the questions you might be exposed to, it will be solve this, solve that. And what are the things you are solving? You'll be given differential equation and you are asked to solve it. 90% of your exam questions are of that format. Given a differential equation, you are asked to solve. When you solve, it is the solution you are getting. So you want to get used to solution concepts. Now, we have different types of solutions, right? When you're talking about solution to a differential equation types, I'm going to list them quickly, okay? Number one, we have a general solution. General solution. General solution. Number two, we have particular solution. Particular solution. Particular solution. Number three, we have singular solution. Singular solution. These are the types of solutions of a differential equation. I am not going to define them, right? I've got a video lesson where I treated a definition of these guys. You see, I'll say one or two things and I tell you I've got video lessons on this channel. Make use of it, become a channel member and you get the full guidance from GMAETS 41. If I come online for you guys at this level, I just pick a key thing and discuss. And mind you, soon the classes will be fully for members only. So you've got to become a channel member, very important. Channel membership is on monthly basis. And you just support GMAETS 41 with a token. For those in Unizik and in Nigeria, based on our currency, monthly channel membership is very much affordable, as low as 2,000 naira monthly. You can just imagine that. Very small compared to the reality on ground. So you see, that will give you room to have access to everything on this platform. Not only for this course, but for other courses. For example, tomorrow I'm going to be hosting a class on statistics for sciences and agriculture. Start 202. You wouldn't want to miss that class. So become a channel member. Is that okay? Support this channel and get the maximum benefit. Right, I told you we have three types of solution to a differential equation. Okay, so you want to take note of that. General solution is also called complementary function if you're talking about second order differential equation. All right. Having said this, you want to take note of this, please. Solution to a differential equation must, I repeat, must contain a constant. Must contain what I said, a constant. If it is first order differential equation you solve, the number of solution will be, the number of constants rather, will be 1. If it is second order differential equation, the number of constants will be 2. If it is third order differential equation, the number of constants will be 3. If it is fourth order, it will be 4. So the number of constants you add to a differential equation is the same as the order of that differential equation. Alright, having said this, I think the time has come for us to just pick 1-2 questions as we close the class for today. And what are we going to do? I am going to give you a solution. That solution is solution to a differential equation. And then we will find out the differential equation that has that solution. This is just a first class to how to find out, that this function is a solution to a differential equation. We are going to do the main thing, the full thing that you are meant to know whenever it comes to solution of a differential equation. Then I am going to put you through the shortcut, fastest approach you need if you are seated in the exam hall. Is that okay? If you are seated in the exam hall, how to quickly solve that gap. So I'm wiping these types of solution as we move on to our first question. I hope you are copying. You can also screenshot. All right, let's move on. So I've got this question. And the question is, find a differential equation from the function. Find a differential equation. Find a differential equation, DE, from the function. It is the same as which differential equation has the function, and the function is given as y equal to x plus a over x. So this is the function. This is the solution. You have been given this solution. You can see that there is nothing like dy dx there. The solution is called a function. You have to find a differential equation that has this answer. You know, the whole concept of differential equation, if you've studied integration, if I give you this and say you should differentiate, if you differentiate this, you now get dy dx. If you integrate that dy dx stuff, you now get back this guy. You know, in basic calculus, you are told if you differentiate a to get b. If you integrate b, you will get what? A. Do you understand that? So this guy as a solution is a solution to a particular differential equation. How can I get that differential equation? Simple. Differentiate this. So this tells you that you need good knowledge of differentiation when you are dealing with ordinary differential equation. And that is not all. You need an outstanding knowledge of integration. As a matter of fact, to solve a differential equation is based on integration. So you don't joke with integration. That is the third introductory part of ODE. The first introduction, like I said, I've dropped the pre-recorded video lesson already in our WhatsApp group. So students on that platform would have already, watched that video lesson and learned from it. The part 2 introduction to ODE is this particular live class. Part 3 introduction will not be a live class. I will drop the link to the video in our WhatsApp group. Why? Because that is based on differentiation and integration. So your concept you expect to learn from there. Integration, very important. Then you get good knowledge also of differentiation. Now let us solve this question, please, and see. Solution. We are given this function y equal to x plus a over x, and we are asked to find the differential equation from this function. That is, which differential equation has this? Which differential equation did we integrate? Because if I give you a differential equation to solve and get an answer, to get a solution, you will have to integrate it to get that solution. So which differential equation has this solution? So what I'm going to do here is simple. I will call this equation 1, that function. Then I'm simply going to differentiate this guy. Because we said that solution to a differential equation is a function that is free of derivative. And then one thing again is that function must contain arbitrary constants. Like here, a is a constant. This is a function of y and x. Y depends on x. This a is a constant. There is no dy dx here. So this is a solution. This function you're seeing is a solution to an unknown dE. So how do we get that differential equation? The function must be a function that you can differentiate. So let us move on. Differentiating this guy with respect to x. Differentiate y with respect to x, you get dy dx. Differentiate this, you get dy dx. Then come to this x. Differentiate this x with respect to x. You're differentiating with respect to x, take note. Because x is the independent variable. Here, y depends on x. Consider that y is equal to something that contains x. So y is the dependent variable, x is the independent variable. All this in part 1 introduction, which I told you I've dropped the video lesson already. All of this have been explained. So if you differentiate this x, you're going to get 1 plus, come to this guy to differentiate. If I give you ax, a over x, and I tell you to differentiate this guy, the first thing you have to do is to rewrite it as ax raised to the power minus 1. Yes. Take this x up to become a multiplier of that a. But using the law of indices, as x is going up, it will change to what? Minus. As in the power, rather, will become opposite to whatever the sign is. Like here, this is plus 1. So if it goes up, it becomes minus 1. If it is minus 1 under here, or maybe minus 2, if it goes up, it will become what? Plus 2 as power. So this is the guy you're now going to differentiate. So you take note. A over x is the same as ax raised to the power minus 1. Let's differentiate this. So differentiate this term with respect to x, you use the power of x to multiply the base, go to the power and subtract 1. This is a polynomial function, you use power rule. Everything about basic calculus, differentiation and integration have been broken down on this channel, 1+1. Become a channel member, get access to all of these. So if I differentiate this term, which I've shown you, this is what it is, you are going to get minus ax raised to the power minus 2. Use the power, multiply this, you get minus 1 times a, which is minus a. Then x raised to power, go to the power and minus 1 from it. You have minus 1 already. If you do minus 1 again, if you do minus 1 again, you're going to get minus 2. So you see that dy dx is actually equal to 1 minus ax to the power of minus 2. Now I'm wiping this part because I've just shown you the way you have to rewrite this if you are to differentiate it. We are moving on. Hi, can you do quadratic equations? Yes, I can. On the channel already I've treated that. Okay, so you can become channel member, send a message to this contact, and I would link you up to the lesson on it, okay? But as we move on, subsequently I'll be picking key stuff from it and treating. So stay tuned, stay tuned, stay tuned. Send a message to this contact, and then you can specify also your need there. We are going to call this equation 2. Now, this is what we are going to do. We have gotten the differential equation. Yes, we have gotten the differential equation. We have gotten the what? Differential equation. The only thing here is that the only problem here is that we still have this constant a. Because if you are getting back the differential equation that has this function as solution, this constant must not be there. Constant must not be there. That arbitrary word, constant, must not be there. So we're going to find a way to remove that gap. We're going to find a way to do what? Remove that gap. So are you ready for us to remove it? How can we remove a from this equation now? We are going to look at the equations we have here and then think of how we can get the value of a. If I get the value of a, I can now substitute. Remember the second definition of solution I gave to you, solution of a dE. I told you it's a function that is free of derivative, which when differentiated as many times as the number of constants and then simplified, it will give you the differential equation. Now I have differentiated this function, this solution. How many times did I differentiate it? Only once. And why did I differentiate once? Because it contains one constant. So all we have to do now is to simplify these equations. We have equation 1 and 2, simplify it, and then you get that differential equation. And what do we do at this point? Like I said, looking at this, you have this unknown constant. It's an arbitrary constant. You are expected to remove it. The differential equation must not contain that arbitrary constant. So what do? I'll go to equation 1 and then try to make a subject of the formula from there. If I make a subject of the formula, I'll now come here and substitute. But take note that this term you have here, please, is the same as dy dx equal to 1 minus a all over x squared. Law of indices. So this is still the same as equation 2. Take note. Let me write this one as equation 2. Negative index law of indices. This x raised to power minus 2 will come down, and then the sign will change to positive. So from equation 1, remember, like I said, our problem now is to remove this a from this equation. So from that equation 1, what will I now do? I'll make a subject to the formula there, then come to this equation 2, remove it. And how do you remove that a is substitute. From equation 1, what is the value of a? Let's make a subject to the formula from here. You know, to make a subject of formula, you clear this fraction. X will multiply this guy, x will multiply this guy. You're going to get xy equal to x squared plus a. Clearing fraction. Your basic mathematics. GMAETS 41 is here to help you. Please, I am begging you now. What you see is I'm going to be applying certain tougher measures. Yes, I've tried. If you've been following this channel, you'll agree with me that I've really tried for students. And I have conquered at least, if not for anything, basic principles of STEM subjects. Maths, chemistry, physics. I have. And I keep encouraging students on the need of activating their basic maths, because it's not when I am teaching courses like this I'll still be wasting much time talking about certain basic things. So to push you into action, I will be a bit tough. Yeah, I wouldn't be completely tough so that you wouldn't say don't understand what I'm doing again. I'll be breaking down the concepts, but please, some of all these basic stuffs, if you have problems with them, indicate. And that is why you must, very important, join this channel, become a channel member, do monthly subscriptions, send your name, where you are contacting GMAETS 41 from, and your level of studies to this contact on WhatsApp. You'll be added to our group. There on WhatsApp, you can now make requests on certain things you want GMAETS to do. Then I will come online. Okay, if we discuss, okay, fine, this is what we're going to do today. I will come online and work on it. I will direct you to this channel right now where you can get information on that. Alright, so making the subject of formula in clearing fraction, the LCM is x. Use x to multiply all the numerator. X times y will give you xy. X times s will give you x squared. Then this x times a will give you ax. That x on top will cancel the x under. So you get this, which means that a is equal to xy minus x squared. What have I done? Make a subject to the formula, move x squared to the left hand side. If this goes there, it becomes minus. Let's call this equation 3. So at this point, substitute equation 3 into equation 2. Remember, like I said, when I differentiated this guy to get this, I've actually gotten the differential equation that has this solution. The only thing that was left for us was just to remove this constant. And you cannot just wake up and pick that arbitrary constant and throw it away. No. You must look at everything you have and then do certain simplification. You make a subject formula from one of the equations you have there, then you substitute there into the differential equation so that it will no longer contain this arbitrary constant. What is happening? I hope network has not started disturbing. Okay. Let's see. The streaming device is hanging a bit, so I'm just let's move on, please. I hope that the network is not disturbing you from that end. Don't know what's happening here. All right, let's move on, please. I've written what you now need to do. So the implication, go to dy dx equation 2. dy dx will now be equal to 1 minus, in place of a, fix this term, xy minus x squared. All this term is a. I notice that a here in equation 2 is divided by x squared. A here in equation 2 is divided by what? X squared. As you can see that on the board. I'm trying to see what the network is doing here. And the 100 level students, be patient. I'll be with you. I hope you guys are ready for your classes. Alright guys, we are moving on. So having done this, we can decide to simplify this part. If you simplify this part, observe something. This term can be written as dy dx. My streaming device is not showing, so I don't know really what is happening. I usually use this to track what's happening over there. Please, can someone indicate, is network disturbing you from this end? Is network disturbing you? Yes or no, please. Because Okay, this one is breaking a little, but it has peaked. Still breaking. Still breaking, I don't know. So please, you can indicate if network is not disturbing, just type no. If it is disturbing, type yes. All right. Felicia Black, thank you for indicating. And you said I don't understand anything. Please, can you tell me your level of learning? Because your level of learning also will determine whether this particular class is something you really follow up with. So indicate your level of learning, let me know. So mathematically, if I proceed, watch something here. This x squared is affecting all this term in the numerator. I'm going to show you below. If I give you xy minus x squared and then I divide it by x squared, this is the same as xy all over x squared minus x squared all over x squared. Yes, it's the same as it. It's the same as this guy. And if that is the case, this x will divide this one of the x in the denominator. And then this x squared and this x squared will divide to give you 1. Which means that the term will now become y over x minus 1. That is what we actually have here. This x squared will divide what you have there. So which means that this term will now become, watch, x will be, this x will cancel 1 from the denominator if you split, because you have to split due to this minus you have here. If it is minus or plus, you split. So this is going to be y left here. You can see I've shown you the simplification. And that y will be divided by 1 of the x, because there are 2x in the denominator being multiplied. Then minus x squared divided by x squared will give you 1. So look at this, because I want to wipe it. xy minus x squared all over x squared. Because of that minus, you can split the numerator over the denominator. Then you reduce. This x will cancel 1 of the x from the denominator. You're left with y over x. Look at it. Then this x squared, this one will divide this x squared. A term divided by itself will give you 1. So I'm wiping this. You are now left with this. Remember that there is no arbitrary constant again. An unknown constant. There is nothing like that. So all you now have to do is simplify this thing towards the option. If it is something that options are provided, you will simplify this towards the option provided. So I'm going to conclude by saying, therefore, coming over here, dy dx will be equal to, this minus can open up this bracket. If it opens it up, let me remove this, you're going to get 1 minus y over x. Then minus plus 1. Plus 1 here. And you can find LCM of this guy. 1 plus 1 will give you 2. 1 plus 1 will give you 2. If you do that, then find LCM of this right hand side. That's going to give you dy dx equal to LCM of this part is x. Then like I said, 1 plus 1 will give you 2. So this is just like 2 minus y over x. And if you work out the LCM, you get 2x minus y all over x. This is the differential equation that has this function as solution. This is the differential equation that has this as solution, that has this function as solution. You can leave this answer like this if you want, but look at this. Can I still decide to do something like this? Or what if I decide to take this x here? This could still be written as x dy dx equal to 2x minus y. Because if it is an objective case, your examiner decides how to write the options for you. So once again, this is the differential equation that has this function as solution. And so the differential equation is first order, because this thing is just dy dx. You differentiated y once. So if I were to solve this differential equation now, if I integrate it, this is the answer it is going to give to me. If I solve this differential equation by integrating, because if you are solving a differential equation to get a solution, it's actually an integration process. Anything that has this, that, and they say you should solve it, it's actually an integration process. You integrate to get the answer. You differentiate a function, a solution, to get the differential equation. And then you integrate the differential equation to get the solution. So that's just what you do in this course. All right, I'm in grade 9. All right, Felicia Black. Grade 9, this is not for you. Grade 9, I don't know from where you are contacting us, but if it is in Nigeria, grade 9 is just JSS 3. Grade 9 is JSS 3, yeah. And the truth is that this particular channel, this particular GMAETS for the ones channel is not meant for basic class, because grade 9 is still basic class. This channel has a special channel dedicated to grade 9 and other levels. Okay, I'm slowly understanding. Okay, that's good. You know, one thing is, if you follow certain things, yeah, irrespective of the fact that this thing is a bit high in terms of your level, you could still understand what is happening there. Yeah, that's the truth. You could still understand, depending on your level of assimilation. You can follow up with gradual explanation. But I have a channel that is specifically for you guys, and I want to type the channel now. That is the channel I'm using to stream, to know what is happening from your end. The name of the channel is GMAETS 41's Basic Class. GMAETS 41. The GMAETS, GMAETS, and 41 together. If you are typing, you don't use this hypersign, this thing like hyphen, you don't put it. And you don't space, just GMAETS 41 together. Then you can now space, and then you type basic, space again, class. So that is the channel name for scholars at your level. Is that okay? Until you get to SS1, that is grade 10. From grade 10, you start making use of this channel fully. Because this particular channel, GMAETS 41, deals with works for scholars from SS1, that is grade 10, grade 11, grade 12, and then undergraduate university students, 100 level, 200 level, and 300 level. But all the same, no knowledge is a waste. If you understand what is being done here, gradually it will even help to improve your sense of reasoning and understanding even the more. They are not difficult, that's the truth. They are not. Alright guys, I've taken my time to show you how we handle this. And I hope you understood it. Finish up what is on the board. You can screenshot. Let me take one more question, then we close this particular class while I prepare for the class for those in 100 level, because I have a particular class for them. Those in 100 level, I have a class with them this evening. This particular class is for undergraduate students, that is university students, in 200 level. Then depending on your school and country, some people might be doing this in 100 level, right? Yes, that's the truth. Some might even be doing it in grade 12 further mathematics. Grade 12 further mathematics. So it's not as if this is only university. No. Grade 12 further mathematics, some schools might be doing this. All right, I'm wiping this, so we take our second question. At least 2 questions solved will help to carry you through. But mind you that we are not done with everything about solution to differential equation, because we still have second order differential equation solutions, and you need to also learn those. In our next class, I'll be treating that. In our next class, I'm going to be fast. Yes, I'm going to be fast. Let's look at this. Given this one is the second order stuff, so I'm going to dictate the question. And this is the question. Find the differential equation that has the primitive. Find the DE that has the primitive. Primitive is the same as general solution. That has the primitive y equal to, okay, let me write it down there. y equal to a sine x plus b cos x. That has the primitive a sine x plus b cos x. Find the differential equation that has this function as primitive. Now how do you solve this? This primitive you are seeing, this function, this solution y equal to a sine x plus b cos x, let's call it equation 1. This equation you are seeing, this function you are seeing, is a solution to second order differential equation. Remember, this one we solved this for first order, that is why you have dy dx. For second order, you have something like d2y d squared x. You have something like d2y d squared x. Does that make sense? How did I know that this solution, this primitive, this function is a solution to second order differential equation? The answer is simple. It has two constants, two arbitrary constants. The constants are a and b. For first order, you have only one constant. Remember, a in that question 1. This guy has two arbitrary constants, so it is general solution to second order differential equation. Now I'm going to solve this question using the standard approach from the definition of solution to a differential equation. However, I'd like to tell you something about this. Don't worry, as you're moving on, you're going to learn better method of solving problems like this. I have a video lesson on that better method, and in fact, best method of getting the differential equation that has this solution. But it is not yet time for me to teach you that, right, in a live class. You can decide to take the video lesson on this channel. Go to the playlist, then tap on playlist on this channel, scroll, you'll see at 202. Look for the video where I created primitive of a differential equation associated to or associated with a given primitive. You'll find those fast lane shortcuts of getting the differential equation that has this. However, like I said, based on what we are learning, the proper thing in this life class, and how to get the differential equation that has a given primitive, we are going to use that definition. Look at the general solution. There is nothing like dy dx here, and that is why we say that this is a solution to a differential equation. We are going to differentiate this guy 2 times. So I will start my first differentiation, dy dx. Differentiate y with respect to x, you simply get dy dx, and that's going to be equal to a sine x. This a sine x, a is a constant multiplying sine x, so you keep a like that as it is and then differentiate sine x. If you differentiate sine x here, you are going to get cos x. So this thing is a cos x. Then you come to this plus, do the same thing, similar, keep b constant because b is the arbitrary constant multiplying this cos x. Differentiate cos x with respect to x. If you differentiate cos x, you get minus sine x. These are basic calculus, which I said I have demystified all the works on basic calculus and even further. This channel got all of them. So this is going to give you minus b sine x. If you differentiate cos, you get minus sine. So you see that dy dx is equal to a cos x, then plus times minus will give you minus b sine x. Call this equation 2. Now, we are still going to differentiate again. Why? I've told you this guy contains 2 arbitrary constants, you can see that. This is the first differentiation. You have gotten first order derivative, which is dy dx. We are going to differentiate this to get second order derivative. Similarly, d2y d squared x, which means second derivative. Now you can see the way you write second derivative. You can say d2y d squared x, meaning differentiate y second time. This is our y. The first derivative gave us this. The second derivative will now be for us to differentiate that first derivative. In fact, this d2y d squared x means d dx of dy dx. That's the meaning. It means differentiate with respect to the independent variable, in this case x. Differentiate with respect to x, whatever dy dx is. This one you are seeing here means d dx of y, which means differentiate with respect to x, whatever y is, which we have y here, you know. So d2y d squared x means differentiate with respect to x, whatever y is, 2 times. Are you following, right? Which I said is written in this format. d dx, differentiate with respect to x, the first derivative. So let us go. This is the first derivative, you're going to differentiate it. Here, keep your a constant, differentiate cos x. If you differentiate cos, you get minus sign. So this guy becomes minus a sine x. Then come to this guy, differentiate it with respect to x. Keep your minus b constant, differentiate sine x. If you differentiate sine x, you get positive cos x. So this will simply be minus b cos x. We shall call this equation 3. And this is cool. We've been able to get our derivatives now, first, second derivative. So with these equations we have on the board, what we now have to do is to simplify and get the differential equation that has this solution. And like I said, it's going to be a second order differential equation. Please let me watch and be sure that the camera is still moving on. Okay, we are 1 hour gone and I have to close this class because I have class with 100 level like I said. But let's round off this. At least you've learned something cool. We are still going to meet in the next class. Like I said, when I say next class, don't worry, we have a timetable we follow. And to learn about this, to follow up with updates, join us. Become a channel member. Support this channel on monthly package. Join the premium level. GMAETS 41 platinum level if you are becoming a channel member. Support us on platinum level, on diamond level. Platinum level is 2,000 monthly. Diamond is 4,000 monthly. And then you join, send your name, where you are contacting GMAETS 41 from, and your level of studies. Send it to this contact on WhatsApp. Request to be added to our group. With that level, we'll know the group to add you to. Because we have group for basic level of learning. There's in primary school, grade 4, grade 5, grade 6, grade 7, grade 8, grade 9. We have WhatsApp group for those in SS1, SS2, SS3, which is grade 10, 11, 12. We have group for those in advanced level. Are you following? And we also have special jam and wide group as well too. Advanced level are those in 100 and 200 level as well as 300 level. So you see, a lot of things on this platform to help you scholars. Now, let us simplify this. Like I said, you see this last equation now. d2y d squared x equal to this. In fact, let me rewrite it. Since I've brought this guy, let me say, therefore, or it implies that d2y d squared x, this second order derivative is equal to this guy here. Look at it. There's something that is common to these two guys. What is common to this a sine x and b sine x? You notice that both of them bear minus. So you can pull out that minus. If you pull it out, open bracket, a sine x. A sine x, then plus b cos x. Plus b cos x. Then we pull out this minus. This become positive, this become positive. So this is your proper equation 3. And this equation you are seeing is the differential equation that has this solution. This is the differential equation that has this solution. Our problem now is that you can't leave this arbitrary constant that is not done. You can't leave it. So we'll find a way to remove this arbitrary constant. And what would we do? We simply have to do simplification. But just take a look at what you have here. Did you notice that from equation 1, because we're going to solve equation 1, 2, and 3 simultaneously. Did you notice that from equation 1, look at it very well, a sine x plus b cos x is equal to y. And that a sine x plus b cos x is exactly what you have in the bracket. So I'm going to write substitute equation 1 into equation 3. So that means that the second order derivative, the 2y d squared x, will now be equal to minus, in place of this bracket, look at it, this whole bracket is equal to y, so you do substitution. See, that is why you learn stuff like simultaneous equation, because that's what I'm doing here. Look at one equation, carry it and substitute somewhere where you find out that there is an equality. Therefore, the differential equation becomes the 2y d squared x plus y. I moved this y to the left hand side, and that is equal to 0. This is the differential equation that has this primitive. This is the differential equation that has this what? Primitive. And you'll be very shocked that, you see this question, if I were to get this answer, you'll be very shocked that this thing would only take me 1 or 2 steps. 1-2 steps in the shortcut method of getting it. Like I said, I have a special video lesson where I taught this already very fast before you know you've gotten the answer. But don't worry. I said what? Do not worry. It is not yet time for you to learn that. Okay? Get to understand this first as to how your lecturers will be teaching you these things when you are in class. Because these are the approach that they use most times that students feel, what is happening here? Or even maybe depending on how this is being explained, students might either understand or get confused in it. But of course, like I said here, whether I use the method your lecturers used to teach you, or I choose to use my method, the shorter approach as the case might be, in either case, the shortcut method is best used if it is a CBT exam, where you have options. But if it is theory, you avoid all those methods, because if it is in theory, your examiner will expect you to follow this process to get the answer. And we are done solving it. And I hope you learned something from today's class. Finish up what you have on the board, please. This device disappointed me. I don't know why it isn't showing anything for me to know what is happening from that end. Okay. But I hope network did not disturb you. Our network did not disturb you. So that is that about our class today. We've gotten the concept of solution to an ODE. So in our next class, I'll be teaching you further on this, and I'll be teaching you the shortcut method of obtaining solution to an ordinary differential equation. Are you following? Yeah, I'll be teaching you that. But before then, there is one more question that I will solve before I start showing you the shortcut method. So if you encounter that in the exam, you wouldn't be, sorry, encounter it either in your lecture hall, or maybe for those that are taking theory on this course in their various schools. If you encounter such question, you can be able to handle it. This is cool. I'll be seeing you in our next class tomorrow. Like I said, I'll be taking those of you in 200 level statistics, start 202. I will be introducing you to something very wonderful. The beginning part of statistics are the concept of frequency distribution, data collection, data analysis, that is interpretation, and data presentation. Right now, some of us may be taking that part for granted. Besides, I just released a video lesson on that. I think yesterday I shared the links to various platforms that I'm able to reach. You guys should be sharing the links to our lessons. Are you following, right? So others can benefit from it. So I'll leave that part a bit. I'll be introducing you to discrete random variable. I repeat, discrete random variable. In that Start 202 class tomorrow. You do not want to miss that class. So stay tuned. Make sure you are subscribed to this channel. Turn on the notification bell. Very important. All those ones are free of charge. To subscribe to this channel is free. To turn on the notification bell is free. The reason is because if you do not turn on the notification bell, anytime I either upload a video or I come on live, you will not be aware. But if you subscribe and turn on the notification bell, once I kick off any class, once I upload any pre-recorded video, either of them, YouTube will just wire you with a notification and tell you that GMAETS 41 is on now for you to go and learn something. Then you can always connect. But our class is usually towards evening, okay? I'm going to release the time for our tomorrow's class. Of course, it's still going to be by 7 o'clock anyway. Sorry that I came on late today. it's for good. It's for good. I went to visit my father, right? Spent some good time with him, and that's why. So I came back a bit late. That was the reason. Sorry about that, but like I say, it was for good. I didn't joke with my father. Love him so much. It is the reason for who I am today. I don't play with him. So tomorrow by 7 o'clock, be on. Start 202. All right, for those in 200 level. Have a wonderful night rest. Share the link of this class to your friends, to your WhatsApp group, departmental WhatsApp group, so that they will also be notified. Come on and subscribe to this channel to be able to learn and prepare very well ahead of your resumptions and examination. Don't think you have time. You don't have time. Time flies like never before. Those in 100 level, I'll be seeing you shortly. Please, the class will start by 9:30, okay? To start by 9:30. Those in 100 level. I've got question I want to solve for you guys based on our previous class, on functions. And these questions for those in Unizik, the questions I'm going to solve, they are part of your Math 102 workbook. Stay tuned.